Yeah, hello everybody. I'm Sharanya, a lecturer in mathematics. I completed my course MSc as well as BEd from Bangalore University. In today's class, we are going to study about an important topic and very interesting one, that is coding section. So let us not waste so much of time. We'll quickly start with the chapter. Let us see what a conics is and what the section is all about. So conic is nothing but any cone. For example, what the cone, as soon as we see about the cone or something like that, we remember the first thing that comes to our mind is an ice cream cone or a very lengthy pen. For that they give the small cap and something else. The cone, the usual cones. Okay, suppose if that cone is intersected by any plane, for that matter, plane it may be a A4 size sheet or A4 size book, anything like that, any plane. When the particular plane cuts the cone at different angles, that is called as the sections of the cone we obtain. So by using the intersection of the cone, we get different shapes. For example, the shapes will be like circle, ellipse, parabola, hyperbola, the major shapes that we get. So in this session, today we are going to study in detail about parabola. Now, why we have to study this conic section? What is the real life application of all these things? So many students will be like, why should we study? Only for the exam sake should we study? So many things that comes to our mind. Being a teacher, think that why they have to study and all those things. So now let us quickly glance through the real life example here. See, parabola is nothing but, as we take the real life example, one example I can give it to you from this presentation, that is the parallel light beam, headlight reflectors, next a path of the thrown ball or water from your lawn sprinklers, that forms a parabola. Next, when it comes to ellipse, it's more or less a egg shape, but it is called as, but if it is not lopsided, the meaning is nothing but the proper ellipse shape should be there. The egg, one side it is proper and the other side it is somewhat like the shape is not so proper, that it gives like a dome shape or something like that. Next, when it comes to the orbits, very important thing, scientific application, that is orbits of the planet around the sun or satellites around the earth. Next comes the hyperbolas, nuclear smokestacks. That is the thing we cannot imagine right now. So next example we can take up is horse saddles, that most of us have seen. Next, when it comes to that, sand hourglasses in narrow neck part, that is, we can just take an example of sand hourglasses that we have seen as well as we have used in so many places, like the timer thing. Now let us see how the cone is intersected at different angles by a plane and how we get the circle, ellipse as well as parabola. Now in this image we can easily see, and whenever it comes to a cone, the first half of the entire cone is not called as a cone. It is called as half cone or a nappy. Now when it comes to the full cone, the nappy, two nappies which intersects or which is combined together will form the particular cone. Now the proper definition of this and the proper image of this you can see right now. The two nappies, when it is cut, that is, we get a full cone which is cut by a plane at different angles. We can see the parabola, the circle, ellipse as well as hyperbola. The part which is cut by the animation, it's given clearly enough. We can see easily the image of ellipse as well as circle. Next, this is the nappy or half cone. Next comes, what is the vertex, how we get this proper cone. Suppose if we take an A4 size sheet and if we roll it into a proper half cone, we mathematically we name a few terms here, that is a surface generated by the line L. Suppose if we take the part of the sheet, A4 size sheet, moving about a circle and passing through a fixed point B, and that point B we always take it to be the vertex of the cone, and when it comes to the line which lies on the line L dash perpendicular to the plane of the circle and passing through the center of the circle is called a right circular cone. And usually this full portion is called as a right circular cone. Suppose if we get half portion, that is our ice cream cone, it is called as half cone. That is a nappy. Next, now how we get all these shapes when the cone is intersected? We can see the proper mathematical definition here. When the section of the cone, that is any part of the cone, which is cut by a plane, that is any A4 size sheet paper, which is when that is parallel to one of the generator. Generator, we can see in the previous image. Okay. Yeah, this one is the generator. We can easily say that is line L through which the cone has been generated. That is called as a generator. When any plane section of the cone is cut by any plane for that matter, and that when that line as well as when it is parallel to the generator, then it gives the shape of parabola. Next, how do we get ellipse? When the section of the cone is cut by a plane which is not parallel to any generator. The meaning is, here comes the generator, and when it is not parallel, as well as it is not perpendicular to the axis. As we know, this is the axis, it is not perpendicular, exactly perpendicular to the axis also, then we get the shape of the ellipse here. Next comes the last image, that is hyperbola. When the section of the cone is cut by a plane which is parallel to the axis. Now this is the axis and this is parallel and intersecting both the nappies. See, this is first half of the cone, that is called as nappy, and this is also the second half of the cone. Put together they form the full cone. Both the nappies is called, and it is intersecting both the nappies. That gives what? The hyperbola. Next, now we are going to see about the analytical definition, the proper definition of the conic section. Now in the general case, we studied what a cone is and what are the different shapes that we get when the plane intersects the particular cone at some angle. Now we'll see the analytical definition, that is called as mathematical definition of the conic section. This is, a conic section is a locus of a point. Now most of you will be thinking what a locus is. So that will be an assignment question for you guys, because you might have studied in the previous class or something like that, or in the previous, that is 10th standard or 9th standard, or if you cannot complete your assignment, I can probably tell you in the next class in a better way. So conic section is a locus of a point which moves such that the ratio of its distance from the fixed point S. Now as you can see this image, this is called as a fixed point S. We are fixing this particular point S to the line L. Now we are naming this line to be L. Is always a fixed positive constant. The fixed point S is called as a focus. That is, we are naming this point to be what? The focus. The fixed line is called as directrix. This line is called as, named as directrix. Now, once again, I'll go back to the definition. The conic section is the locus of a point which moves such that the ratio of its distance, ratio, the meaning is there will be one numerator term as well as the denominator term in a simple language. So the ratio of its distance from the fixed point, this particular point, distance from the fixed point to the fixed line, is a positive constant. So for that, we are going to take any point on a plane. That point we are naming it to be what? P. So distance from the fixed point, that is PS, divided by PM is equal to any fixed constant. You can name it to be E, you can name it to be B, you can name it to be A, for that matter, anything of your choice. Next is, if P is a point on the conic section, as we have seen in the previous slide, there is a point P over here, that is on one particular plane. Now as the definition also we have studied, PS by PM is equal to A or E. Now this particular constant A, we are naming it to be eccentricity. So it's like a mathematical term, and we always denote this particular point to be E. Now what are the different cases that we get? Suppose this particular value E, if it becomes 1, or if it is less than 1, or if it is greater than 1. So usually we take the values to be what? 0, +1 and -1 in general. So we are dealing only with 1, less than 1 as well as the greater than 1 values. So now if this eccentricity is, when it is equal to 1, the conic what we get is will be in the shape of what? The parabola. Next, suppose if the eccentricity E, if it is less than 1, the conic will take a shape of an ellipse. If the eccentricity E is greater than 1, the conic will take a shape of hyperbola. Next, the general equation of the conic section. Now, when it comes to mathematically, we have seen the definition as well as the different varieties of the how the cone, where the cone is intersected by a plane, what and all the shapes we get, and why we use all those things we have studied. Now we are into purely solving the mathematical equation as well as few application problems as well as the general problems regarding the conic section. So now comes the first derivation under conic section, which is the general equation of the conic section. What is the general equation now? To derive the equation of the conic whose focus is h comma k, the directrix is ax plus by plus c is equal to 0. See, as we can see in this, the directrix is what? A fixed line. So equation of a line in the general form, we write it to be what? Ax plus by plus c, which is equal to 0. Now the focus is h comma k. Any point we are taking, so that focus we are considering it to be any point h comma k. So that is yes. So in the previous thing we have observed here, yes, that is the focus. Now any point we are fixing here, that is called as p of x comma y on a plane to be any point in the conic section. So by the analytical definition we have studied ps by pm, ps by pm, which is equal to what? E. So from that we get ps by pm is E. So cross multiplication gives us what? ps is equal to E into pm. We are squaring here. Why? Because we are going to use the distance formula wherein we get square root. To avoid the square root, what we are going to do is initially we are squaring on both the sides. So we get ps square is equal to E square into pm square. So ps. So ps. Now we have taken s to be what? H comma k, as well as p to be what? X comma y. Using distance formula we get x minus h the whole square plus y minus k the whole square, which is equal to retain E square as it is. Now when it comes to pm, pm is what? Distance from this point to the directrix. So general equation ax plus by plus c divided by modulus of the distance. So root of the coefficient of x the whole square plus coefficient of y the whole square. The whole square. Next comes, this is the locus of the point P of x comma y and hence it is the equation of the conic section. Now after simplifying all this, the square, eliminating the square, or after squaring on both the sides, cross multiplication, after doing all the process, we get the quadratic equation in x. So general equation is ax square plus 2hxy plus by square plus 2gx plus 2fy plus the constant c, which is equal to 0. Now in today's class, till now we have studied about a cone, half cone, as well as when a cone is intersected by a plane, we get major three shapes, that is a circle, ellipse, parabola, hyperbola. Sorry, there the 4 shapes. Now in this session we are going to study about the first and very important conic, that is parabola. So what are the today's objective? What do you mean by the parabola? How to write the equation of the parabola in the standard form? What are the graphs of the parabola? That means the left-handed parabola, right-handed parabola, upward parabola, downward parabola, and the simple problem as well as some application-oriented problem we are going to study under today's class. So first of all, we'll study the definition of the parabola. That is, a parabola is a set of all points in a plane that are equidistant from a fixed line, the directrix, and a fixed point, the focus, that is not on the line. See, previous slide, we have seen that when the eccentricity is equal to 1, the conic we get is called as what? The parabola. Now, based on that, PS by PM will be what? 1. The ratio will be 1. E will be 1. So, the parabola is a set of all points in a plane that are equidistant from the fixed line, that is from the directrix, and the fixed point, the focus. So, here is the focus, and here is any one point P that is not on the line. Next, let P of x comma y be any point. Here we can see any point on a plane, and this is our focus. This is a plane which is divided into quadrant. Now this is x-axis positive x, this side will be negative x. This is the origin, y-axis, and the negative y-axis. Now the focus is, the point lies entirely on the x-axis, so its y-coordinate is equal to what? 0. So we are taking that value to be a comma 0. When a point lie on xy plane, this is called as xy plane. So the P of the points will be the x comma y. Next, when it comes to this fixed line, as we studied about this, is called as what? Directrix. Now this is on the left side of the origin. So this point we are going to consider to be any value. We can name it to be R, S, T, anything for that matter. R you can name it because already we have taken it as S. So I just took it as Z. So as it lies on the negative side of the x-axis, its coordinates will be minus a comma 0. Now the point of intersection from here, P, we are going to draw a line to the directrix, and this line is called as PM. So P of x comma y be any point on the parabola, then by the analytical definition we have distance of P from S. This distance is equal to distance of P to this particular line L. So that is PS by PM is equal to 1, as because the eccentricity is equal to 1. So after cross multiplication we get SP is equal to PM. Why I am taking modulus here? Because as we know very well that the length of an object or the distance of the object cannot be negative. So to avoid the negative, we are going to consider this to be modulus. So modulus SP is equal to modulus PM. So squaring on both the sides, just to avoid, as I told you earlier, just to avoid the square root, we are going to square it on both the sides. So SP square is equal to PM square. That is, SP square is equal to PM square. SP square is equal to Zn square. Why I have taken Zn square? See, this particular line. As this particular line is parallel to this particular line, this particular PM is parallel to what? Zn, and this distance, both the distance are same. That's the reason we don't have any coordinates for M. So it will be very difficult for us to simplify the equation. So with respect to PM, we are taking one more line, that is equal line, that is called as Zn, because PM is equal to Zn. Now SP square is equal to, as this O is a midpoint, we can write this to be OZ plus ON, the whole square. So SP, using the distance formula, x2 minus x1 the whole square plus y2 minus y1 the whole square. So already we have squared it, so no need of writing the square root. So directly I am writing this to be x minus a the whole square plus y minus 0 the whole square, that I have written as y square, which is equal to OZ. See, distance from O to S is a, distance from O to Z is what? Minus a. So here we can just take the length, cannot be negative, we are taking it to be what? A, plus this particular value x. ON is what? X. So this ON is equal to x, the whole square. So simplifying the equation, a minus b the whole square, we get x square minus 2ax plus a square, y square as it is. A plus b the whole square on the right hand side, x square plus 2ax plus a square. Cancelling the same terms on either side of the equation will be left out with y square on the left hand side plus 2ax on the right hand side, and minus 2ax to the right hand side, it becomes plus 4ax. So that is the standard equation for the parabola. Now we'll see equations and the graphs of parabola. So first is Let me show the diagram first. Yes. Now, this is the right-handed parabola. This we are going to call it to be right-handed parabola, or the description here I've written symmetric about x-axis opens right-hand side. So here when it comes to this, F, it's a focus, and line D, that is called as directrix, this is called as vertex. As we have seen the standard equation of the parabola, that is y square is equal to 4ax. The vertex, see, this is clearly origin. So origin, the x coordinate as well as y coordinate is what? 0. So vertex is 0, 0. Focus. Ma'am, in the earlier diagram, you've written the focus to be S and you have taken here it to be F. It's your wish. You can take this to be focus. So F or focus. If you feel like the last word, I'll take it. Last letter, I'll take it. You can take that to be yes. Anything for that matter. So F, which is equal to A, 0. Now the directrix, as it lies on the negative side of the X. See here, you can clearly see. This is the origin, this is negative x-axis, this is positive x-axis. So line x is equal to A will be the equation of the directrix. So the parabola is what? Symmetric about the x-axis. Now when it comes to, when the parabola is symmetric about x-axis, but when it opens up to the left-hand side, that is y square is equal to minus 4ax. So here the focus is what? Minus A, 0. And the directrix is on the positive side of the x-axis. So x is equal to A. So its vertex is same. It is at the origin 0, 0. Focus is on the negative side of the x-axis, that is minus A, 0. Equation or the length of the directrix, equation of the directrix, that is x is equal to A. And the parabola is symmetric about x-axis, open towards the left side. Next comes the different set of parabola. That is, a parabola opens upward or opens up. Now for that matter, the parabola is symmetric about the y-axis. So equation changes to x square is equal to 4ay, where the focus lie on the what? Y-axis. When the point lie on the y-axis, its x coordinate is 0. So f is equal to 0, a, and the vertex is at the origin. So vertex is 0, 0, and the focus is 0, a. And the directrix lies on the negative side of the y-axis. So y is equal to minus a. And the last type of parabola, that is parabola opens down, that is downward parabola. Now the same vertex is at the origin, that is 0, 0. Equation is x square is equal to minus 4ay. And the focus lies on the positive y-axis. So negative y-axis 0, minus a, and directrix lies on the positive side of the y-axis, so y is equal to a. Next, let us quickly see a few examples how to solve, how to find the equation of the parabola, or how to find the focus as well as directrix of the parabola. Now find the focus and directrix of the parabola, which is given by, the equation is given by y square is equal to 8x. Now, if we compare this particular equation to the standard equation of the parabola, y square is equal to 4px or 4ax for that matter, it's your choice. So 4p directly we are equating it to what? 8. So from this, 4p is equal to 8, p is equal to what? 2. It's a positive value, as because p is a positive value, parabola is with its x symmetry, because parabola lies on what? This particular positive x-axis. So focus is a, 0. That is 2, 0. Next example, suppose if it is on the negative. If the now in this case, when the parabola opens towards the right, the directrix will be on the left hand side. That is x is equal to minus a. So as we got the a value to be plus 2, directrix equation will be x is equal to minus 2. So taking the general equation, y square is equal to, given equation 8x, y square is equal to, substituting both the values, 8 into 2, that is 16. So we get two different values, plus or minus 16, that is plus or minus 4. So there are two possibilities for the focus. On the positive side of the x-axis, we get 2, 4. On the negative side, we get 2, minus 4. Next, one important thing we are going to study under parabola, that is latus rectum. Now let us see what a latus rectum is. The latus rectum of a parabola is a line segment that passes through its focus. See, now this is the focus, the line segment. It has to pass through the focus, not through the vertex, because if it passes through the vertex, then it is called as y-axis. It has to pass through what? Focus, and is parallel to the directrix. Now this is our line L, that is called as directrix, and this particular line which passes through the focus has to be parallel to directrix, and it has endpoints on the parabola. That means this is the shape of the parabola and the endpoint should be on the parabola. The length of the latus rectum for the graphs of y square is equal to 4ax or 4px for that matter, and x square is equal to 4py is. See, here it is given clearly, y square is equal to 4px, length is equal to 4p, as the focus is p comma 0 here. 0 comma p is the focus here. X square is equal to 4py, standard equation of the parabola. Latus rectum length is 4p. Next, find the equation of the parabola from its focus and directrix. Finding the standard form of the equation of parabola, with focus it's already given, directrix is also already given. Now the equation, when the x value is given and when the point lie on x-axis and when the y coordinate is 0, the parabola definitely a right-handed parabola. So we can take the standard equation to be y square is equal to 4px. So focus is 8 units. So p is equal to 8. Next, y square is equal to 4px. Substituting the value y square is equal to 4 into the p value is 8 into x, we get 32x. So equation of the parabola we get, that is y square is equal to 32x. So we have seen 3 different cases. The standard equation was given. We found out the focus as well as equation of the directrix. In this problem, the focus is given, the equation of the directrix is given. We need to find what? The equation of the parabola. Next, one application problem here. Focus is on the y-axis. That means a point lie on y-axis, so its x-coordinate will be what? 0. So form the equation is the point 3, 4 lies on the parabola. So let us take the first point x to be 3, second point that obviously p of x, y. So x is equal to 3 as well as y is equal to 4. So we get, substituting in the general equation, x square is equal to 4py, because the parabola is opening upward here. So 9 is equal to 16p, p is equal to 9 by 16. Next, we'll take this, the previous value, that is 9 by 16, and we'll substitute in the general equation of the parabola. X square is equal to 4py. So after substitution, x square is 4 into 9 by 16 into y. So x square is 9 by 4 into y. So x square, the equation of the parabola used to shape the mirror is x square is equal to 9 by 4y. The light source should be placed at 0, 9 by 16 or 9 by 16 inches above the vertex. Thank you so much. In the next class, we are going to study about the 3 more shapes, that is ellipse, hyperbola, as well as in detail about the circle. Okay, thank you.